Titration. Titration is a way for us to determine an unknown concentration based on a known concentration. You use indicators and pH meters. An indicator is a compound that changes color as the pH changes, and a pH meter shows a digital readout of the pH value. So the two indicators that you have to be aware of is phenolphthalein and litmus paper. Phenolphthalein is clear in an acid and pink in a base. Litmus paper is pink when it's dipped into an acid and blue when it's dipped into a base. There are many other types of indicators. This chart shows an example of different chemical indicators besides phenolphthalein. Now, if we use phenolphthalein, the color change actually occurs around 9. So if my titration needs to show me the color change in the range of a pH of 9, then I need to use phenolphthalein. If I need to have the color change occur around 11, I might want to use this indicator. If I was using methyl orange, that color change happens between 3 and 4 of a pH. So you can choose different pHs depending on when you need your color to change. So a titration, you add known concentration to react completely with an unknown concentration, and it determines the equal moles. The equivalence point is when the two solutions are equal moles. The indicator is determined by that point. So if that point is at 5, pH of 5, then I want my indicator to change color at a pH of 5, so that when the color changes, the end point is the same as the equivalence point. Those are two different definitions, though. So in this problem, I know that this is a titration problem because it says titration. And what we're dealing with is molarities and volumes. So we're using the M1V1 equals M2V2 dilution equation. But because we're doing acids and bases, we could change that to say A for acid and B for base. So I need to look for my information on acids and bases. 25 milliliters of HCl, that's my acid. What is the molarity of HCl? For my base, 38.28 milliliters of 0.4370 molarity NaOH. So then I just need to plug in my numbers. I don't know the molarity of my acid. The volume of the acid was 25 milliliters, and that equals the molarity of my base times the volume of my base. Now the volume does not have to be converted here because we have V1 and V2. So as long as V1 and V2 are in the same unit, you don't have to convert the volume. So then we just solve for X. So when I multiply, I end up with this, and then on this side I would have 25 milliliters X. So to get X by itself, I would divide by 25 milliliters, so that cancels this out. My milliliters will cancel, leaving me with molarity. And X would equal 0.6691 molarity. So again, I know I'm going to have a titration problem because it will say titrate or titration, and then I know to look for information about acid and information about a base. So 20 milliliters of HBr. What is the molarity of HBr? And for my base, I have 20 milliliters of 0.1819 molar of NaOH. So then M1V1 equals M2V2. Instead of 1s and 2s, I could have A for acid, B for base, and then I just need to plug in my numbers. Molarity of the acid, again, is what I'm looking for. The volume is 20. Molarity of my acid times the volume of my acid. Again, the volume does not have to be converted since we have V1, V2, as long as they're in the same units. So when I multiply, I get this number, and that would equal 20x. So to get x by itself, I would have to divide both sides by 20. Milliliters would cancel, leaving me with molarity. And x would equal 0.1824 molar. One more time. I know that I have a titration problem because it says titrated or titration or titrates, some form of that word. So I know I need information on acids and bases. So if I read the question, 1.605 molar sulfuric acid, 24.09 milliliters of the acid, 50 milliliters of NaOH. What is the molarity of the base? So I know M1V1 equals M2V2, and I could change that to be acid and base. Plugging my numbers in, my acid molarity times the acid volume equals x times the base volume. So to get x by itself, we would simply divide by 50 on both sides. My milliliter will cancel out, leaving me with molar. And I would have 0.7733 molar as my answer.